Okay, so this is organic too. I'm not sure how I feel about this. Should put a note here without. I like the space compared to this morning where there's literally students right here in that room, but if we need to move closer, we can certainly move them closer at some point. Okay, so this organic two, you just have is a syllabus. You have some review questions, and you have this, which will replace the flicker cards, and we'll use that to answer some questions. Okay, a couple things. In terms of the class website, I'm just going to go over a couple of things here. So everything is loaded for the class, including the syllabus, the reading assignment, which you have, as well as how to purchase the textbook. The company indicated that if you purchase the year long, that if you type in the code, it'll automatically recognize that. So basically, you'll have like 2 copies of the textbook. The reason that I had them do a new copy is because they had some videos and stuff that were new. So I just said, go ahead and do that. I made the first 12 chapters just like practice only. So you should have that in the new copy as well, so you can go back. For those of you who are just getting the top hat for the first time. So that code will be the class. And everybody was in the system, so I'm assuming that everybody was in lab last semester. In terms of the Piazza discussion board, there's a new Piazza for Chem 222. As you can see here, somebody already posted a question about these packets. You are going to turn in the Scantron bubble sheet next week. And you can see that it truly does say posted by anonymous. So when you post anonymously, I can't see who you are. So that is literally truly anonymous. So some people use this a lot. Some people never logged in. I would say it's a good thing to keep track of because I do answer a lot of questions there. And as you can see here, you can ask questions anonymously. I will have it set up so that if in the middle of class, if you want to type in a question, I will see it on another screen here so that you can ask questions that way. You can, of course, always raise your hand and ask questions or not raise your hand. But if you're kind of squeamish about asking questions, feel free. I'm not sure how I like the two screen thing either, but we'll get over it. So that's available for the lecture and then also for my lab section. Now, the way I would like to do the class this semester is a little bit more in terms of flip, but to make sure that everything is explicit from day to day. So if you everything is here, links, how to play the narrated homework keys when I have practice problems or I narrate homework keys. There's video there, link to my appointment calendar, the syllabus, the reading list, the day-by-day schedule, which is the first one there, and then previous years, both 221 exams and previous 222 exams. And then today's folder, which you didn't have, which maybe you watched the video ahead of time. If you did, fine. If you didn't, I'm going to go over some of that today. So for Wednesday, you're going to go back through. So what I'd ask you to do is to at least either read the book or watch the video, or both, depending on how much time or how much stuff makes sense for each section. So for instance, for today, if you were coming to class today, the reading assignment would be here. And so we're going to talk about alkynes, structure and bonding, synthesis, acetylide ions, and elimination reactions, and that's probably as far as we're going to go. the addition reactions we're going to get to on Wednesday. So this would be the sections of either the textbook or the video that I would ask you to watch for today. Okay? And again, you're going to get a chance to do that, so afterwards you can. Now, when you're looking at the videos, the videos are all tracked to, or there's time stamps in the video once you go to YouTube. So for instance, I'll just get that folder back. So when you said, okay, pre-class lecture notes, the pre-class lecture note would be where the PowerPoint is that is used in that presentation if you wanted to print it out. There's also a video. So if you push the button on that video, you will get this video, which will then down here will have a timestamp. So for instance, the structure, bonding, and alkynes is at 7 minutes, 36 seconds. Stability, formation of alkynyl anions, which we're going to talk about, and then the preparations of alkynes. So you can go to a specific section using those timestamps. So that's the way all the videos are set up. I had them already for second semester. I don't know how much of this I did first semester, but for second semester, they're all there. So that means that if you wanted to watch, if you're taking the approach, I'm going to read through the book, I don't quite get this, you could watch the video, or you could watch the video first and then read through the book. It doesn't matter to me. But I would like you to be familiar, at least have taken a look at either the book or the video before you come to class. So that way, if you have questions, you can ask them. We'll probably take the first couple of minutes. I will open up, Piazza will be open up. If you have questions, when you come in, you can immediately type them into the Piazza and I'll see them. Again, you can do that during class. You can do it outside of class, and you can just say, hey, would you go over this? And then I'll put it down in my notes to go over. Okay. So that's, all of them are set up that way. I'm not sure if you click on this, if it will automatically fast forward you to the thing. I think timestamps are, I think if you're monetized, timestamps demonetize you, but I'm not monetized. I wish I was sometimes. Okay, so that's how we're going to set it up. And I will try and send you out an email like at the end of the class period saying, for next time, these are the sections, and watch the video. I would like you to try the problems that are in Top Hat. Those are still graded on participation. But if you have to take 4 guesses to get it right, that might be something you want to ask about. So, and I can track how many people got the question right on the first time versus multiple times. So I'll take a look at it and say, oh, well, maybe this is what I need to start with. But I will always start with whatever questions you have first. Okay, so it's always laid out like that. You can't see the problems, but if there are problems, there'll be some graded problems. Sometimes there'll be just practice problems, and there'll be an answer key with the practice problems, which there are there. It's just they're not highlighted, so you can't see them, but I can. Okay, so that's what we're going to look at. So if you go to Wednesday, there's Wednesday's video, notes, and video. Are we done with that sheet? Or are we still signing? Okay. You can just hold on to it and I'll get it after. Okay, so that's how we're going to structure the class. And like I said, that was ideally how I hoped it would happen last semester, but I'm going to be much more intentional about trying to make sure everything is clearly more laid out. We have 4 exams this semester. If you look at the syllabus, there are 4 exams this semester versus 3 last semester. The reason that there are 4 is because basically this semester what we're going to do is we're going to go through reactions. So this semester is going to look a lot like the end of last semester in terms of reactions. So you can groan if you want. That means we're going to go through sometimes maybe a half a dozen reactions in a day. What I'm also going to do then is I'm going to try and have a 5-minute quiz before class starts on last time's material, so that it kind of forces you to keep up with the reaction so you don't get too far behind. So we'll have those. We won't have those probably this week, but we'll start those next week. And once I start them, I can't stop, because if I stop, then I stop for the rest of the semester. So, of course, I got to start at some point, but we'll do that next week. Okay. Okay. What else in terms of the syllabus? We're going to have exams are the formative, which mean or summative, which means they're the high stakes things. The formatives, there'll be in-class quizzes, the graded homework problems from Top Hat, which again are graded on participation, and then there'll be some graded problems that I will give you and collect up. Now, when I collect them up, I will either explicitly grade everything, or I will just take a look at it and make sure that you've done, made an attempt. You will not know which is which. I don't know which is which. So that means you should probably take those and try and do them as best you can. Again, there's no amount of points that are going to make up for that work, right? Where you get your points on that is you're prepared for the exam. So if you do all of these things, come exam time, you'll be more prepared. If you don't do them, again, it's all about practice. You want to get good at something, you need to practice. And so if you don't, the first time you're going to see a problem on the exam, and this semester is going to look much more like the end of last semester. So that's probably not going to end well if you're just practicing on the exam, unless you're a super genius, at which point, and only you would know that. So I would just, practice, and that's what all of this is there for. Let's see. So on Friday, the professional development, the career services office is going to come in and give a quick presentation on how to access and how to do the career assignments that I've given you this semester. It's LinkedIn and interviewing. If you didn't get your resume or your cover letter approved from last semester, probably a good thing to do that, but that's not going to be graded this semester. Your completion isn't going to count for anything, but it will count if you're, looking for internships over the summertime. So 2 things they suggested: an earlier deadline, because they can't deal with a week to give me that information, which is perfectly fine. So we have an earlier deadline on that, and then also they wanted to come in and show you where everything was at. So they're going to do that on Friday. And I will give you prompts during the semester that, hey, if you haven't done this, think about it. I think that was about it. You can read the rest of the syllabus. It's the same as last time. You have the reading list then day to day. That really won't vary all that much. If I don't cover something, we may pick it up in the next day, but we'll pretty much use that as our guide to make it through the semester. Okay. All right, any questions? Okay. Then, let's start with alkynes. So, what are alkynes? Carbon-carbon triple bonds. Now, for each functional group, and this is the way that the class is organized, all books are organized this way, all successful books. Those that use an alternative organization usually go under. But all books break things up according to functional groups. Last semester, we talked about alkanes and alkenes. Now, there was a lot of stuff with alkanes. Stereochemistry, conformations, and then alkenes. This time we're going to start with alkynes, go to alcohols, etc. So for each functional group, we're not going to talk much about naming, although the videos will have naming on them because that's the way the other book is set up. But we talk about naming, in the first month or so. But then we're going to talk about structure and bonding, or structure physical properties. How do we make that functional group? How do we react that functional group? And so everything's going to be organized that way. So the first part, which I want to talk about in the limited time today, because this is going to be one of the few times where I actually lecture without you having read anything or watched anything beforehand, is how do we make a triple bond? And there's two methods. One I call from scratch, and then there's one that's cheating. And the cheating method is you take a triple bond and you add something to it. So there are two types of triple bonds, alkynes. There is an internal triple bond that has the two R groups attached to the carbon-carbon triple bond, and there is what is called a terminal triple bond. And then if there were no alkyl groups, it would be C2H2, which is called acetylene, which is basically a gas and isn't very helpful unless you burn it. So of these two, my first question, there's going to be a lot of review today, so if you're like, oh my God, I don't remember any of that, write it down, because you'll need to go back and see if you can remember it. If not, ask. But my first question is going to be, which one of these two is more stable? Now, the clickers are okay, but the problem with clickers is if there's two number 37s, that gets messed up. So I had these on my desk from a conference in Dayton over the summertime, so that's why you got it. So this is what we're going to use to answer our questions. What you want to do is you want to fold it both ways, so that way you can choose whatever answer you want, and you can show it to me with no peeking. Although what I'm always going to do, even though this room isn't too bad, is I'll probably always give you a minute or so to discuss if you'd like, and then ask you for your answer. So we could move the chairs around into groups, but I think everybody's squished in here pretty tight. So that's my question. My question first is, which one of these two is more stable? And so I'll give you a minute to discuss, to think about that, and then you can go ahead and give me your answer. So which one is more stable? A is going to be the internal and B is going to be terminal. Okay, it sounds when the volume goes up and then down, it usually means people are ready to answer. Okay, what's your answer? Which one is more stable? I guess I didn't put C if they were the same, but they're not going to be the same. Okay, so I see mostly A's with the B thrown in. So why would A be more stable? Joya?
More highly substituted.
It's more substituted. So what? Does more substituted mean more stable, Sarah?
Electron density.
So in other words, triple bonds look an awful lot like, where did we say last semester, more substituted, more stable? What functional group was that last semester? More substituted, more stable. You only got two choices, alkanes or alkenes. Alkenes. As a matter of fact, triple bonds, you're going to see for Wednesday, the triple bonds All the reactions with alkenes are going to almost be identical for triple bonds, except 2 pi bonds and a triple bond. That means you can add twice as much stuff. So last time we added 2 BRs. This time I can add 2 BRs, or I can add 4 BRs. I can add 2 H's or 4 H's. So a lot of alkene is going to carry over to triple bonds. So more substituted, more stable, yes. So A is more stable. Now the first method to make an alkyne is to use an alkyne, to basically put an alkyl group on the end. So let's say I had something like this. I have a terminal alkyne, and what I would like to do is I would like to react that with a base to deprotonate my terminal alkyne. I want to pull the hydrogen off of the end of the triple bond. And I want to turn that into what is called an alkynyl anion. My ultimate question here is going to be, what base should I use? But in order for me to talk about what base I need to use, I need to review and remember the periodic trend for basicity. So in the periodic table, we have a C, an N, an O, and an F, which means my choice is which one is a stronger base, CH3 minus or F minus. Now the question I'd like you to answer is, does basicity increase going from right to left, which would be choice A, or left to right, which would be choice B? So on the periodic table, horizontally, how does basicity go? In other words, who's more basic, CH3 minus or F minus? Okay, give you a couple seconds, minute to discuss. Do we have an answer? Okay, what's our answer? Does it go left to right or right to left? Okay, I see A's up. So it goes, so basicity, so that means CH3 minus is a stronger base than F minus, which is true. CH3 minus is going to be the strongest base that we have this semester. We're going to talk about that more in the next chapter, when we talk about how to make a CH3 minus. So that means that basicity increases as we go from right to left. Okay, now I'm going to ask that question because the reason you have a review packet in front of you, and it's a little long, but that's okay. You got 2 weeks. And my purpose is to get all the stuff that was in, not all the stuff, but a good chunk of the stuff from last semester that has escaped back in, because you'll need it. So there may be some review. How did I come up with those problems? First thing I did was I used last year's problems, which came from the year before, which came from the year before. How did I get those problems? I looked at the multiple choice questions on the final exam, and some of the ones that were missed the most, like 11% correct. Or lower. And so I didn't put those exact problems on here, but I used modifications of them. And so one of the things that, we were worn down at the end of the semester is trying to remember, okay, well, how does the basicity trend go? And so it goes from right to left. So CH3 minus is a stronger base. Now, the question is, if that's a C minus, then how do I deprotonate it? Well, it turns out that an sp3 C minus is the strongest base of all, but an sp C minus is actually much less basic than that. So I'm going to say that this C minus on the triple bond is approximately the same basicity as an O minus. And with limited time today, I won't get into the example of that. It has to do with S character versus sp3. It's only 25% S character, whereas sp is 50%. So that has a trend towards being a weaker base. So that means that if I wanted to make a C triple bond C minus, I need to think about that as forming an O minus. So my next question is going to be, can you give me a base that I could use to make that C triple bond C minus? I'll give you a minute to discuss or think. What base would you use to deprotonate that carbon to make it a C minus? And it's got to be 100%. It can't be equal.
Because I feel like anything too strong too would just have to
It's just more
because you don't want
That's okay.
Okay, does anybody have an example? There's a couple different answers for this. Tommy?
NH2 minus.
NH2 minus. Do we agree or not? Do we agree NH2 minus would work? Okay, does anybody have another one? Notice I didn't say whether it would work or not yet. Another one? Why'd you choose NH2 minus? And remember that when you answer a question, you can ask a friend or pawn the question off to somebody else, but I'm usually going to ask why. I'll probably start with the person that answered the question, but we're in one of those where what's that gym like? What's the gym? It's the no guilt zone or whatever it is. we're still kind of we're in that as well. So there are no wrong answers because that's an answer that, okay, why doesn't that work?
This is a strong base.
Okay, it's a strong base. Anybody want to help them?
I have no idea. We said maybe.
Don't start your answer with I don't have any idea. Because if you didn't have any idea, you don't have an answer.
Okay, well, it's an idea, but I don't know if it's a right idea.
And don't say if you don't know if it's right or not, I will tell you what it's right.
But we said because it wouldn't like break down into any other like substituents that would add on to the carbocation. it would just kind of grab the hydrogen and it would leave the carbocation as an ion.
Okay, so there's no carbocation.
Or like
The carbanion.
alkyl-
It's called a carbanion, and we'll get more into that. Anybody? All right, for this, if we think of this as an equilibrium, if we think of that as an equilibrium, I've got a base on this side of the equilibrium, and I have a base on that side of the equilibrium. If I want to push that equilibrium that way, if I'm comparing bases, the base that's going to be on the side that I want, which is the right side, what kind of base does that have to be? Stronger or weaker than the one on the left? It's going to have to be weaker because equilibrium always pushes towards the weak side. So that means I want that base to be weaker. So I want that C minus, which is approximately an O minus, to be a weaker base than the one that's going to be on the left that I'm using to deprobe. So if I go to my simple periodic table here, here's my O minus. I want a base that's stronger than O minus because that's what I would like to make, essentially. So what are my choices? N minus and C minus. So NH2 minus is a perfectly good choice. And the reason is because it's stronger as a base than the C triple bond C minus. And again, the C triple bond C minus is approximately an O minus. So in the next chapter, I'm going to ask you again, how do we make an O minus from an OH? And if you remember, you're going to say, oh, we can use NH2 minus or a C minus. So we can use NH2 minus that we used last semester, as well as a C minus like CH3 minus, which we don't know how to make yet, but we will in the next chapter. Okay, so you can use NH2 minus or you could use CH3 minus to make that alkyne, that alkynyl anion. Okay. So if we're going to deprotonate something, we always want it to be a stronger base than what I'm making. And for the most part, we can use the periodic table to figure out how strong that base has to be. Now, I don't know if you used NH2 minus in your Organic 1 class. If you weren't in mine, you might have used something like an N minus with 2 isopropyl groups. That's an LDA molecule. That is the sterically hindered version of NH2 minus. In my class, we used NH2 minus as our small base. Then you probably used the CH3O minus as your small, strong base. We'll get to that. We'll get to that in a chapter. So remember, my overall goal is to add something to the other side of the triple bond. I'm going to synthesize a triple bond from a triple bond. It's cheating. It's not really all that exciting, but it's what I have to do. Okay. So that's the first step, deprotonate C triple bond, CH. So now I've made my alkynyl anion. Now I'm going to react it with an alkyl halide to hopefully add that alkyl group. We'll call this R1. So I would like to do that reaction, and I'd like to replace basically an H with an R group. So what kind of reaction is that? Close. SO2. and not kind of like SN2, SN2. So let's just go back. SN1, if I wanted to do an SN1 reaction, well, let's pull off on that. So this is going to be SN2, which means the alkynyl anion is a what? In SN1, SN2 terminology, the C minus is the nucleophile, right? It's the nucleophile. What kind of nucleophile? Strong. So the C minus, the C triple bond C minus is a strong nucleophile. It is also a strong base. It is both a strong nucleophile and a strong base. So that means that if I want to do this reaction, and my choices are a primary, secondary, or tertiary alkyl halide, when will that act as a strong nucleophile and do an SN2 reaction? With which one or more of those halides will it do SN2?
Primary or secondary?
I hear primary and secondary. It'll do SN2. Do we agree? Which means we have to do what? We have to remember from last semester that chart where we predicted the reaction depending on the strength of the nucleophile versus the primary, secondary, or tertiary halide. And so if you have a strong nucleophile and a primary or secondary halide, you have SN2. And I'll write that chart out and I'll put it in today's folder if you don't exactly remember what it looks like, or you never had it to begin with. Okay. But primary and secondary undergo SN2 when they react with a strong nucleophile. Now, my definition last semester of a strong nucleophile is anything with a negative charge. But this is truly a strong nucleophile. If it's the equivalent of an O minus, that's also a strong base. Okay. So, yes for primary, yes for secondary. Why didn't you say tertiary? Will a tertiary halide undergo SN2? No. Why not?
More than one step.
It does take more than one step. Why does it take more than one step? Because it's too hindered. All right, SN2 means nucleophile is going to come in and attack. If it's tertiary, that means it's too hindered for the attack to occur. So if you're the C triple bond C minus, and I told you there'd be a lot of review. So if you're like, whoa, I don't remember that, write it down. And then you can go back and take a look at your notes. Or if I need to review that, I'll do it on notes. So if you're the C triple bond C minus, and you can be both a strong nucleophile and a strong base, your tendency is to be a strong nucleophile first. And we're going to have strong nucleophile, strong base combinations. And again, I give molecules human characteristics. And so the first thing it wants to do is do nucleophile. It wants to do nucleophilic attack. If it cannot, it gets a little angry, and then decides to come in and rip off a beta hydrogen to do E2. So in this case, that alkynyl anion, if you react it with a primary or secondary halide, you're going to have no problems putting the alkyl group on the other side. If it's a tertiary, it's going to do E2 and form an alkene. So you cannot place a tertiary group You can't put a tertiary alkyl group there because that will undergo E2, not SN2. Now you might be saying, but if it's a tertiary, it can form a carbocation. Yeah. The strong nucleophile base, it isn't waiting. It doesn't wait for a nucleophile to form. It acts. It either attacks or it deprotonates, but it doesn't wait around for a carbocation. So it's going to do either one of those. So if you want to add an alkyl group to a carbon-carbon triple bond, what you do is you take a terminal alkyne, deprotonate it, react the alkynyl anion with a primary or secondary halide, and you do what is called an alkylation reaction. Alkylation reactions mean I'm adding an alkyl group to the molecule. This is the first synthesis of a triple bond. And again, I think it's cheating because you need a triple bond to make a triple bond. But look at all the review it gives us. It gives us review about basicity trends, about the chart of when SN1 and SN2 occur, when E2 occurs. And so we'll get into a little bit more of this on Wednesday. So this is method 1 to make a triple bond. It is not from scratch. From scratch would be to think about, okay, how did I make a double bond using this E2 reaction? Well, I had a leaving group attached to the carbon, which was usually a halogen. The leaving group attached to the carbon, that carbon was given a Greek letter. The carbon with the leaving group is the alpha carbon. And then what's attached to the alpha carbon? The beta carbon. And what does the beta carbon have attached to it? A beta hydrogen. So if you want to make a double bond, what you need to do is take your molecule, add your leaving group, and then make sure there's a beta hydrogen to be removed by the base. Now that hydrogen just cannot be willy-nilly any place it wants to be, right? It has to be anti-periplanar to the leaving group. Okay, so that's something we have to remember, is that the beta hydrogen will have to be anti-periplanar to the leaving group. Now the good thing about this is, from a reaction standpoint, is I can't form a triple bond inside of a cyclohexane ring because the angles don't match up of 180 degrees versus 120 or 120 in the ring. So all those problems we did where we were like, okay, do I remove this beta hydrogen or not, are in play. But if I want to make a triple bond, what do I need to do? I need two of these. Because what I like to do is do 2 E2 eliminations. So I have a choice. I could say, all right, let me put my bromine there and my hydrogen there. So in other words, put 2 bromines on the same carbon, which is what is called a geminal dihalide. And so then if I now react this with 2 equivalents of base, my first base molecule will come in, deprotonate the beta hydrogen, kick off the bromine, and then my second equivalent of base will come in, grab that hydrogen, and kick off the bromine. Of course, there's a double bond intermediate in between here, which I should write. So in other words, after the first bromine is gone, then this is where the second base will come in, grab the hydrogen, and kick off the bromine to form the carbon-carbon triple bond. So this is one method, a double E2 elimination of a geminal molecule. The problem is, I don't know how to make a geminal. We didn't do any reactions to make a geminal system to put two bromines on the same carbon. Now, as you'll see in the reactions for Wednesday, if you want to make a geminal system, you need a triple bond. Again, cheating. We're not making it from scratch. But I will leave you with this. I could do that same thing if I had this system. If I had two bromines next to each other, or on adjacent carbons, which is called a vicinal dibromide, I could do the same thing. Have the base come in, grab one hydrogen, kick the bromine off. The other base comes in, grabs the other beta hydrogen, and kicks off the bromine there. And so I can make a triple bond in between the two carbons with the bromines from a vicinal system. I know how to make that. So do you. Maybe not right this moment, but you will by Wednesday. Okay, so that's the other way in which to make a triple bond. So we'll kind of finish this up. If you have any questions about this, put it up on Piazza or email me. So for Wednesday, you can go through these topics, and then the topics for Wednesday, they're in Canvas as well, and I'll send out an email to that effect. If you have any questions, though, put them up on Piazza and bring them to class on Wednesday.